Okay, since I'm out, I thought I would go old school and give you guys a blackboard, and we will go through and check out a couple of problems off your homework. Actually, we'll do all 6, so then that way you've got answers for it and solutions. So for problem number 20, they have going and returning, and those two distances are the same, so we're going to set those equal to each other. So their going here is going to be rate times time, so it's going to be 50 times x. Coming back, they were going 55 miles an hour, and they took 32 hours round trip. So if they've already spent X hours there, then they would have 32 minus X there, and that's how they came up with that. So when you solve this, and again, this should be nothing new for you, but when you get this, you get 5x, I take that like 105x, is equal to 1760, divide that 3 by 5, and you get, and it says, what's the distance between the two cities? So, your time here turns out to be like 16.76, so almost 16 3/4 hours. So that means that your distance is going to be 50 times that. Is 838 miles. Okay. Question number 23, they give you a nice picture. Let's see if I can get that in here. Hey, there we go. Ta-da. Sorry, playing around with the other. So now notice here what's going on. They tell you that Janet is running 5 miles an hour, which means that she'll be going a total of 5 times t, which is the amount of time that she's running. Russ is going a total of 7 times t because they're going 7 miles an hour. So this whole distance from here to here is how much distance Russ ran. So that's equal to 7t. Janet started and stopped after t was 1.5 miles behind, and her distance is 5t. So basically, this is the segment addition postulate from last year. And so from that, you can then assume that, or I shouldn't say assume since the two are equal, you're going to have 5t plus 1.5 is equal to 7t. And that's 7t, not 70. So anyway, so then you're going to go through and you're going to solve it. So you get, take that back, so 1.5 is equal to 2t. So then t is going to equal 0.75, and that's in hours. And the problem says, how long before they would have? So I mean, that would be okay, 3/4 of an hour. You could probably also say that's going to be 45 minutes then. That is, if you could tell that word was minutes. Ta-da! All right, we'll do 3 problems on this one, I suppose. I was going to do 2, 2, and 2, but I think this will work. Problem number 25. Problem number 25, track events. Tim Montgomery set a world record, 100 meters, time 9.78. This pace could be maintained for an entire 26-mile marathon. What would his time be? Okay. So, a couple of things. Now, this is going to basically amount to being a giant ratio or a dimensional analysis problem. You may have heard called stoichiometry. Basically, you follow through and you're going to do a series of conversions. Okay, so here, Tim did 100 meters in 9.78 seconds. Okay, so he took 9.78 seconds to go 100 meters. Okay, so now what we have to do is we have to then convert this into miles. So they tell you here that 1 meter is equal to 3.281 feet. So that means that here the meters cross off. So now, if I were to multiply this out, I'd be figuring how many seconds per feet that we would have. Okay. So then I would have to multiply this again. Oops. Sorry. By, because now we need to get this into miles, actually 26 miles. So I have 5,280 feet in 1 mile. Just a tad. So the feet are going to go away. So now I've got seconds, over miles. And so we could also then have to multiply this through by technically 26.2 miles, which is a full marathon. They're saying 26. So 26 miles. So that's going to be your overall time. So now the miles are going away. So now all we have is straight time. So now if I were to multiply this out, I would get this really large number that's all in seconds. So if you're going to if you're going to multiply all of that out, you'd currently be sitting at, let's see, 4,092 seconds total for 26 miles, so for 1 marathon. So this is 100 miles per marathon. Now, we need to convert this ideally into something better. So we're going to convert this into minutes. So 1 minute has 60 seconds. And then I would dare say we could probably do hours. So I'm going to say, okay, that means that 1 hour has 60. Well, actually, you know what? Let's pause there for a second. Let's multiply this out and see what we get. So you're going to take that 4,092 divided through by 60, and you're going to get 68.2 minutes. So then what you can do is you can say, okay, well, that's going to turn into 1 hour, 8 minutes. If you need to know if you really want to do it, you're going to take that 0.2 times 60, and you're going to get 12 seconds. So that is much, much faster than the fastest marathon time of 2 hours and 5 minutes. Okay? So there's that one. I'm going to go ahead and pause this and stop so people can jump around to the next one. See you in a minute.